Hello student, today we are going to derive a very important question for the examination point of view. Let us look at the question. Establish the criteria for spontaneity, non-spontaneity and equilibrium in terms of entropy, internal energy change and entropy change, Helmoltz function and Gibbs function. At first, we'll do in terms of entropy change of the system. Entropy is equal to ds is equal to dq by t. We know dq is equal to d plus p dot dv, and this t comes here, and d is equal to where d is equal to internal energy, and dv is equal to volume of the system, and p is the pressure, and t is the temperature. We know, and by from here we get t dot ds is equal to d plus p dot dv. If dB and te are kept constant, if dB and dB are kept constant, that is when you keep it constant, by the derivatives of dE we get 0 and the derivative of dB is equal to 0, then that is t dot ds means keeping internal energy and volume constant, then what you get, that the result is equal to 0, and at equilibrium condition it happens and the process is reversible. If t dot ds ev is equal to 0, then and the process is reversible, and when the energy is less than 0, then the process is irreversible. When the energy is greater than 0, the process does not occur, that is it is non-spontaneous. The process is non-spontaneous. And in terms of internal energy change of the system, here entropy ds is equal to dq by t is the similar case, and where dq is equal to d plus beta dv by t. D is equal to internal energy, dv is equal to volume of the system, t is temperature, and p is the pressure, and t dot ds is equal to de plus p dot dv, and this d is equal to t dot ds minus p dot dv. If dv and ds are kept constant, that is when you keep this ds and dv constant, and we get, that is to keep constant mean dv is equal to 0 and ds is equal to 0. At that time the system is equal to, then what the result will get is that internal energy de at constant and entropy and volume, and we get the system is reversible, that is it is at equilibrium condition, and if it is less than 0, then the process is irreversible, that is spontaneous process, and if the system is greater than 0, the process does not occur, that is it is non-spontaneous. In terms of enthalpy change of the system, by the definition of enthalpy, S is equal to E plus PV. We know this comes from definition of enthalpy. When complete differentiating, we get dS is equal to dS is equal to T is equal to dE plus P dot dV plus V dot dV. We apply a chain rule. Applying chain rule, then we get this. And then also we know the T dot ds is equal to dE plus P dot dV. This is from first law of thermodynamics. First law of thermodynamics, putting the value in equation 2, putting this value of T dot ds, putting the value of T dot ds in equation 2, we get ds is equal to T dot ds is equal to, this is here is ds is equal to, instead of this dE plus P dot dV, this is also dE plus P dot dV, we get the same result. So ds is equal to T dot ds, instead of d plus P dot dV we get T dot ds plus V dot dP is here. If ds and dP is kept constant, if we kept dP and ds, here we keep this pressure and this entropy is constant, then what happened, that is ds is equal to 0 and dP is equal to 0, then we get the result. If it is equal to 0, then the process is reversible, that is equilibrium condition. If enthalpy at constant entropy and pressure is less than 0, the process is reversible, that is spontaneous process. And ds, that is del enthalpy E at constant entropy and pressure is greater than 0, the process does not occur. That is non-spontaneous process. In terms of Helmholtz function, by the definition of a Helmholtz function, A is equal to E minus ds is equal to 1. On complete differentiation, dA is equal to dE minus t dot ds minus s dot dt. This is equation 2. We know t dot ds is equal to dE plus p dot dv. This from the this is comes from the first law of thermodynamics. Similarly, this is from the first law of thermodynamics. Then what we do here, put in the value of t dot ds. We put this value of t dot ds here. Here we get the equation. We get d is equal to de minus instead of d we get minus de minus p dot dv minus s dot dt. d is equal to minus p dot dv minus s dot dt. If dv and dt are constant, that is dv is equal to 0 and dt is equal to 0, then what we get here is it dA it Helmholtz. For Helmholtz it is for del A at constant volume and temperature. The is equal to, if it is equal to 0, then the process is reversible equilibrium process, and del A at constant volume and temperature is less than 0, the process is irreversible, that is spontaneous process. And if the system is greater than 0, the process does not occur, that is it is non-spontaneous. Now we'll discuss about in terms of Gibbs free energy. In terms of Gibbs free energy, by the definition of Gibbs free energy, we know G is equal to S minus Ts. We know enthalpy S is equal to E plus PV. Putting this value in equation 1, means here we put this value of S here. Then we get the relation G is equal to E plus PV minus Ts. On complete differentiating, dg is equal to dE plus p dot dv plus p dot dp. We apply here chain rule. Then we get the result p dot dp minus t dot s. For this t dot s, we get the minus t dot ds minus s dot. We also apply here chain rule. Then we get this result. This is equation 3. Actually, we know. Also, we have to know from this formula of first law of thermodynamics, you know t dot ds is equal to d plus p dot dv. Putting the value of t dot ds in equation 2, we put this value of equation t dot ds. This value we put this t dot ds in equation. This we put here. Yeah. Putting the value of t dot ds in equation 2, dg is equal to then what you get here is dg is equal to de plus p dot dv plus b dot dp. Instead of t dot ds, we get d minus de e minus p dot dv. This is minus p dot dv minus s dot dt. Then this p dot dv and p dot dv is cancelled out, and this d is cancelled out. Then dg is equal to v dot dp minus s dot dt. If dp and dt are kept constant, if dp and dt means pressure and temperature are kept constant, when you give the temperature and pressure constant, that dv is equal to 0 and dt is equal to 0. That is Gibbs free energy dg at constant temperature and pressure is equal to 0. Then the process is reversible, that is it is the equilibrium process. And if it is less than 0, then the process is irreversible, it is spontaneous process. If it is greater than 0, then the process does not occur, it is non-spontaneous process. I hope student you understand my this lecture, and I try to solve your most of the problems. Please, if you like, comment and subscribe my channel if you like it. Please, thanks for watching my video.